Hi, welcome to Conf42 DevSecOps Days. I'm really excited that we get to talk about container scanning today. We're going to dig into adding container scanning to a DevOps pipeline. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker. It's a royal pain, which is why you can go to robrich.org and click on presentations here up the top. And here's container scanning runs fast and stay safe. The slides are online right now. While you're here on robrich.org, let's click on About Me and learn about some of the things that I've done recently. I'm a Cyral developer advocate. If you're struggling with your data mesh, I would love to learn from you. I'm also a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your neighborhood, hit me up on email or Twitter, and let's get a GiveCamp near you too. Some of the other things that I've done, I do a lot with container and Docker and Kubernetes training and consulting. If you have that need, hit me up. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into container scanning. Now, we talked about this guy. Doesn't Kubernetes just do this for me? Well, kind of. Let's take a look at what is Kubernetes. Oftentimes when we're greeted with Kubernetes, we have a diagram kind of like this. It shows the control plane here in green, it shows the worker nodes here in blue, and we can see the various components, the microservices within Kubernetes. Now there's lots of microservices here that do a lot to keep Kubernetes running, but they focus on keeping Kubernetes running. They do nothing for our process in our container. Now, maybe when the user comes in, if they don't have the right port or host name, they won't get past the load balancer. But once they're inside the pod, once they're inside the container, if they can compromise that container, they can easily pivot to any other pod within Kubernetes. Kubernetes does nothing for protecting the security of the process running inside the container. Okay, so we don't have anything in Kubernetes. Let's flip over to Docker. Now here in Docker, we can compare Docker on the right to virtual machines on the left. With Docker, we still have a hypervisor. We still have the same sandbox that we have with virtual machines. So the processes can't communicate with each other with shared networks, with shared memory space, but they can communicate with each other like virtual machines do across the network. So if we're running Docker Swarm, or even if we're running containers inside of Kubernetes, this container can reach out to this container, and this container can reach out to this container. There's nothing inside Docker that keeps us secure from a process perspective. We still need to manage the process here. So both from Kubernetes and from Docker's perspective, they are responsible for keeping track of their pieces. We're responsible for the content in our container. We could think of Kubernetes much like a firewall in front of the container. Now, Kubernetes will do a lot for keeping track of our process, and if it crashes, it'll restart, but it doesn't do a whole lot for making sure our containers don't get popped and making sure content doesn't leak. Now, Kubernetes does have namespaces, but namespaces are not a security boundary, they're an organizational boundary. Once we schedule content within Kubernetes, every container is available to every other container over the network. Kubernetes focuses on keeping Kubernetes running. It's our task to secure the process in the container. So what is a container? Well, a container has a file system, it has users, it has a process, it has ports. This looks a lot like a Linux machine. And we know how to secure a Linux machine. That's easy. We can do processes like making sure we're not running as root, removing excess users, removing unused software, keeping software up to date. It's pretty standard stuff here, preventing unauthorized access into our system. Well, it's a Linux machine, except the way that we accomplish that is a little bit different. These are ephemeral, isomorphic, and deterministic hardware. They're short-lived, unchanging, and the same every time. Now that's really cool. That means that we don't run Patch Tuesday inside of a container. Rather, we build a new container and replace the existing container with that new content. Now, if we're going to replace the container, that works out really well. We just build a new container, and we know that the content in that new container now has the patches that we need. That also means that we don't really need to keep track of what's running inside the container, because at the point where we created that container, that's when we established that. Now, if a container does get popped, that's easy enough. We just evict that container and spin up a new one. We may need to compensate for damage that it pivoted to, but we don't need to, for example, scrub the system. So securing containers. By default, every container can communicate with every other container, both inside Docker and inside Kubernetes. Now, that makes sense, kind of. It makes our processes, our microservices really discoverable, but if we're going to want to limit traffic across our Docker switch or around our Kubernetes cluster, we'll need to use a service mesh to do that. By default, if we pop any container in the cluster, we can now pivot to any other container in the cluster. Now, all of our internal methods now have IP addresses. That's why we have all of our microservices. So if you're able to pop any of our containers, all of our containers are now at risk. As we look at threat vectors, we can look at threat vectors coming from outside. Maybe we have CVE and installed software. Maybe our app has a vulnerability that gets exploited by incoming requests. Or maybe we've exposed secrets inside of the content that we distribute to machines. Maybe the app didn't render that, but maybe we included more data than we should have. And these secrets could come from outside, but they could also come from underneath. Maybe our container is running with excessive permissions, or maybe our software has a vulnerability that makes it wake up and do unexpected things. We can kind of group these into the threats coming from outside, the threats coming from underneath, and then once we're compromised, what can they pivot to? Wow, this sounds a lot like Linux. So the good news. Because these are ephemeral, isomorphic, and deterministic hardware, if any of our machines get compromised, if any of our containers get compromised, we don't have to do a big scrub. We just shut them down and create new ones. Now that's really nice. We do need to keep track of what did they pivot to and probably restart those containers as well. But for the most part, the damage is done and we've removed it. We don't need to uninstall things. We don't need to scrub stuff out. This deterministic hardware ensures that we're the same every time. That's actually really good for container scanning as well, because once we know the contents inside of a container, we know the contents. We've established what's running inside that container, and we can take that list of software and compare it against a CVE database to know if our container is compromised or what software we might need to upgrade. Now, as we start talking about a DevOps pipeline, we'll start running tests against our system. We might have unit and integration tests. We might have static analysis of our source code. We might have open source license compliance. We might take inventory of our machine for known vulnerabilities. And then finally, we'll take all of these results and we'll compare it to our corporate level of tolerance. Now, it's really easy to say, if any of these tests fail, we're not going to deploy. But what if there's a vulnerability that is not patched? What if we don't have a vaccine for this threat? Should we shut down our business until there's a vaccine present? Should we hobble along? Should we deploy it anyway and see how we can manage that risk? It's possible that we may choose to say, yes, if there's a vulnerability in our things, it's still good to push it. It might be better than the content that we have running in production because we've been able to patch other things. So let's take a look at each of these types of tests. As we look at unit and integration tests, there's nothing new that I can add here. You need to do it. Running unit and integration tests helps us validate our software. And even so much more as we start running our builds more frequently and deploying this content into production. A good suite of unit and integration tests helps us validate that updated libraries don't cause harm to our software. In short, unit and integration tests. You should do this. Next up, let's take a look at static code analysis. Now, there's lots of different tools that we can use for static code analysis. This is where we start to look at our source code and see if we can find problems or vulnerabilities inherent in the way we've built our software. Now, I'm not here to pitch a software product, but as you grab these slides from robrich.org, you can click on each of these blue links to be able to get more information about these products. Hopefully that will help you to get past the blank page and discover the product that is the best fit for you. Static code analysis can help us avoid vulnerabilities within our system. Now, as we avoid these vulnerabilities, then we can build more robust systems. Next up, license analysis. Now, here's some more software products. Grab these slides from robrich.org and click through each of these blue links to be able to take a look at ways that we can validate our licenses. Now, what if we include a GPL library? Does that mean that our entire system needs to be open source? If that's a concern, validating the dependency tree and the license requirements associated with that may be really important to the organization. Take a look at these software products and pivot to the software product that works great for your environment. Now, let's take a look at policy validation. Now we have the results of our static analysis, we have the results of our unit and integration tests, we have the results of our license. And now we're given the choice to go or no go. If we have any failing unit tests, should we not deploy this new version of the software? If we have any license validation adjustments, should we fail the build? Now these are great checks to make. We may need to take a more pragmatic approach though to say, well, it's better than it was, or we need to get this patch out right now because we're losing a whole lot of business. And the fact that there's a failing test really doesn't help us to solve this really urgent concern where we're bleeding money out of our organization. So we may choose to have a different risk policy associated with the urgency of the deployment. So where's the serverless in all of this? We've been talking for some time about adding testing and validating our software within our DevOps pipeline. Where's the serverless part? Where's the container part? Yeah, all of this so far is principles that work in DevOps pipelines, whether you're focusing on containers or whether you're focusing on any other type of software. You'll have unit tests, integration tests, static analysis, license validation, and let's add in the container space, container scanning. When we take a look at container scanning, our task is twofold. The first is to discover the content that we have running in our container. Now we need to look at the libraries that our application depends on. We need to look at the content that we have installed in the operating system. And depending on our programming environment, we might have multiple sets of libraries. Maybe our website has our back-end libraries, but it also has some node libraries to be able to construct our front end. In this case, we need to inventory all of this software. We need the package name and the version number. Now, the great thing, once we have this inventory of software, we can compare this against a list of known vulnerabilities. Is any of our packages vulnerable? Or what severity is the vulnerability? Are any of these packages patched and should we upgrade? Now this is great. That's the purpose of container scanning. We inventory our software and we compare it to a list of vulnerabilities to take a look at what software might be vulnerable. Now the great thing here is once we've inventoried our software, our container, we know at that container hash all of the packages that are installed in our system. So periodically we can re-compare that software list to our vulnerability database and understand if our container is newly vulnerable based on newly discovered vulnerabilities in some of the software installed in our system. We don't need to rescan the system. It's an ephemeral, isomorphic, and deterministic system. If there's any problem, we can evict that container and start up a new one. But we know exactly the content that's in that container. We just need to continually compare it to our vulnerability database. So when should we scan? Now here's where we add some creativity to this process. There's lots of points where we can scan our container and based on that comparison, validate if our container is vulnerable. Now the container scanning process does take a while. So if your goal is to have a 10-minute build and container scanning takes 10 minutes, then you won't be able to complete the container scanning within the build allotment. So maybe we schedule the scanning, but we validate the results downstream. Or, depending on our policy, our risk assessment, maybe we just accept that our build is now going to take 20 minutes instead of 10. Yeah, the process of discovering the software within our container is pretty involved, and it takes a while. So when can we scan? Well, we could start off by putting a process inside of our DevOps pipeline. The beauty here is that as our software gets built, we can go build up this image, and once the image is built, but before we push it to the registry, we can kick off the process that will inventory this image. And then perhaps we compare that to our vulnerability database and identify if there are any severe threats within our container. Now, this is all before we've pushed it to our registry. And if we can wait that long, then we know exactly when this software is vulnerable, and we can block that thing from even getting into our registry if it's too vulnerable for our taste. Now, next up, we might choose to include this scan in our container registry. What if we have some content that is pulled straight from Docker Hub or another registry and isn't built through our DevOps pipeline? We may need to scan our container registry periodically to understand if there are any new containers that might be vulnerable and added to our registry. Now, in the case where we pull a container and push it into our registry to be able to use it directly, then this is a great place to catch it. We could also just enumerate all of the containers. We know that if we've inventoried our system with this particular container hash, that we already know the content that's in there. So we can just quickly scan through our registry, validate that we've inventoried each of the containers there, and then continue matching that inventory list to our vulnerability database. Now, next up, we could scan the content in our cluster. Now, arguably, it's too late. Our content is already running, but if ever there's content that we pull directly from Docker Hub to start in our cluster, then this is kind of the only place that we can catch it. Now, arguably, you should probably pull the content and push it into your own registry so that you can validate it first. But if ever we have a pod that directly references external systems, then we'll probably need to scan our cluster as well. Now, the assumption of each of these is that that's the process where all things flow through. So if we're going to pull content from another registry, then we can't just scan in the DevOps pipeline. If we're going to pull content from Docker Hub and not set it into our own registry, then we can't just scan our registry. We need to take a look at the content running in our cluster as well. And there's one more spot: Kubernetes webhooks. Kubernetes webhooks are a great place to be able to catch the content because that's the pipeline that starts pods within our system. Let's double click into that and take a look how it works. Now here, as we take a look at the Kubernetes webhook story, we have a mechanism that has two spots where we can tie into it. The first is the mutating webhooks. Now in series, each webhook gets called and it gets to change the YAML associated with this request. Here's a spot where we might inject sidecar containers for authentication or other resources. Next up, we have a validating webhook. Now it calls each of them in parallel, and each one gets to say yes or no. Now, perhaps at this point we say, hey, that container is running as root. We're not going to let it through. We could also, at this point, go quickly inventory the system and validate that there are no severe vulnerabilities within our containers. Now, if this is the first time that we've seen this container image, we may not have enough time to complete that full container scan. But if we have seen this layer hash before, then we can probably just go look at the vulnerability database and validate that this system isn't too vulnerable to be able to get started in our cluster. So Kubernetes webhooks is a great place to be able to start, give that go or no-go signal into our cluster. Because if we say no, then that pod, that container, won't even get started in our cluster. That's great. Everything that starts in our cluster is going to go through this process, so that validating webhook is a great place to be able to dig in and do some final container scanning. Now, hopefully we've already seen that image before, so we're just validating the results. If this is the first time we've seen the image and it takes 10 minutes to inventory the software, then we're not replying in time, and that validating webhook is probably going to fail straight away. So maybe we fail it, and in 10 minutes, once we have the results, we try again to schedule that pod. So these are the various places where we can take a look at our content, and each one has value depending on where we have the content. If we're going to always rebuild every image, including the images from other sources, then putting it in our DevOps pipeline might be sufficient. But if there are any containers that aren't built in our DevOps pipeline, we'll need to also add content into our registry. Now, if there are any images that aren't pulled directly from our private registry, but are pulled from a public registry, then we'll also need to add either a Kubernetes validating webhook or a periodic scan through our cluster. And the Kubernetes validating webhook is a great place to do that double check. Nothing will start inside of our cluster if we've stopped it at the validating webhook. Now, what should we use for container scanning software? I'm definitely not here to pitch container scanning software, and there are many more choices than this. But this might help you get past a blank page. As you grab these slides from robrich.org, click through each of these links to be able to take a look at that software and choose the one that best resonates with you and your organization. Now, your choices may be different than mine, but for the purpose of demos, I do need to pick one, so I will reluctantly pick Anchor, maybe alphabetically, but Anchor is free and open source, so it's not a bad choice. It is definitely not fast, but it does a good job. Anchor, it's free and open source. It runs as a set of microservices, and it will do the inventory both of operating system packages and of app packages. It's great for container scanning for CVEs, but it is not fast. The docs are also not great. Let's take a look, though, at how we might include Anchor scanning, and when you choose the particular software that you're going to use, then you can use the same methodology to run your build. Our first stop in Anchor is to download the Docker Compose file. Now, this allows us to be able to start up the Anchor microservices. What I find interesting about this is that it is a suite of microservices, but this Docker Compose file just starts the same image a bunch of times, passing in different arguments. So is it microservices? Or is it a distributed monolith? That's an argument for another day. Once we've got Anchor started, then we can Docker Compose exec or pip install Anchor CLI to be able, pardon me. Once we've got Docker Compose up, we can do a Docker Compose exec or a pip install to be able to get at the Anchor CLI. That Anchor CLI will allow us to run the commands necessary to be able to get at the container scanning content. So whether we've exec'd in or pip installed, we now have the Anchor CLI and we can begin the process. First step is to do an Anchor CLI system status that will tell us about the content that we have running. Now that's perfect. We have all of our microservices up. We know that the Anchor system is ready. And the next one we do is an Anchor CLI system feeds list. Now, as part of listing the feeds, it will kick off the process of syncing the virus definitions. The vulnerability definitions. Now they have vulnerability definitions for each of the package managers, NuGet, NPM, Maven, and they also have a vulnerability list for each version of Linux. So we have Red Hat and Ubuntu and Alpine and each of the versions of these so that we can take a container and we can inventory it in all the ways. Now, the docs say that it takes about 10 minutes to populate all the scan data, but let's take a look at the one that I did. Here's my, feeds update. We can see that I started on the 20th and I finished on the 23rd. Yeah, that was a little bit more than 10 minutes. Okay, so we've taken a look at how we get the Anchor system updated. Now, once we have that list of feeds, actually, let's take another look at the list of feeds and take a look at these things. So we have Gem, Java, NPM, NuGet, Python, And that's really great because we have the vulnerabilities for each one of the package managers. We also then have vulnerabilities in each version of Alpine, including the Amazon 2, CentOS, Debian, RHEL, Ubuntu. And so if you have an operating system listed here, you'll be able to get at the vulnerabilities in the packages that might be installed in that operating system, together with the packages that you may have installed as part of your application. So that's the next step, is grabbing the content and using that to be able to check our container to see if our container is vulnerable. Let's take a look at the commands. Our first step is an anchor CLI image add, and we'll give it that container. Or rather, we'll give it that image and version. Now this will queue the process. It won't actually execute synchronously. Now if we choose, we can do an anchor CLI image wait, and that wait will wait until that task is done. So now we've got the build spinning for maybe 10 minutes. Now that's fine. We're taking a look at this image and we're waiting for it to be done. And once it's done, then we can take a look at the results. Anchor CLI image get will get the results, and we can further filter those results based on the inventory list or the vulnerability results. As we take a look at the vulnerability results, we can choose the particular type of results that we'd like. Now, in this case, I'm looking for all, but we could also look for those specific to a type of package manager or the operating system. And that will export that list of results in JSON. We could also take a look at the list of installed packages. So I'm going to take a look at the content, and in this case, I'm going to take a look at the content across all the systems. Now we can save that list of content off, and later we can recompare that list of contents against our vulnerability database. Did a new vulnerability get discovered? We can quickly identify the active containers that we have that particular version installed. So now we know immediately which builds we should restart to be able to secure that software from that vulnerability. So let's take a look at how we might integrate this build. I have here a regular build that just does the normal things: Docker build, Docker push, Kubernetes apply. Now that's perfect. This DevOps pipeline, maybe I'm kicking it off from TeamCity or Jenkins, and it's just running this script to be able to run the content. Now, how would I add container scanning? Let's come in and we'll add all of those anchor commands. So after I've built my content, before I push my content, I'm going to go run these anchor commands. Now in this case, I'm going to pass in not only my image name, but also my Docker file, so Anchor can do some additional checks. And I'm going to choose to wait. So yeah, this may take a long time, but I really want to make sure that my container is good before I push it into my container registry. So once it's done, I'm going to go grab the results in JSON format, and I'll export those to vuln.json. Now, next, I'm going to take a look inside that vulnerability.json and look for anything that is vulnerable. If there's anything that's vulnerable, I'm going to fail the build. Now, we talked previously about how that might be a little bit aggressive. What if there's a vulnerability that doesn't have a cure? Should we block the push? Or might we want to just push it anyway and take extra care with that build? Now, there's probably patched software in other places, so just saying that there is any vulnerability at all might not be pragmatic enough for our organization. Now, depending on your needs, that might be exactly what you need. Let's take a look at that vulnerability.json. Here's that list of vulnerabilities, and we can see the CVE, we can take a look at the content, and we get severity. In this case, it's medium. And we know whether this CVE is patched. So in this case, there is no fix. A medium vulnerability with no fix. Should we block pushing? Should we let it go? Maybe a pragmatic approach might be no high vulnerabilities and no unpatched vulnerabilities. That might be a good pragmatic guess. Okay, so once we've identified the things and we've talked about how this is likely not all of that practical, we can next take a look at the content that we've got. So let's take a look at the content. And yeah, that's a wall of packages. This JSON wasn't formatted very well. So instead, let's take a look specifically at the content just for my operating system. Here's all the packages and their versions. So I can now take a look at the content and compare this periodically to my vulnerability database to know if my software has become newly vulnerable based on recently discovered vulnerabilities. I'll save both the vulnerability list and the content off to a safe spot where I tag that together with the image hash. And now I can recheck that container periodically to know if that image has been newly compromised. Now, once I've validated this image and I know it's good enough, now I'll push that to my registry. Now I know that only things that have been validated are in my registry. Well, what if a software package becomes newly vulnerable but is currently in the registry? Should we purge it out of the registry? Well, maybe. If it's the image that is currently running in production, what if a pod needs to restart? Now, maybe there's no image that it can use to restart. It might take a more pragmatic rather than a more absolute methodology here to say, well, let's purge old containers out of our registry that are vulnerable that aren't also in use. Okay, so we've modified our build to include container scanning, and this was really helpful in being able to get this anchor build to be able to validate that our software is not vulnerable in the way that is tolerable for our build. Now that was great. We can do that for an on-prem build. Let's also take a look at how we might do this with GitHub Actions. Now the cool part about doing it with GitHub Actions as opposed to doing it on-prem is that GitHub Actions will keep the database up to date. So we don't need to sync the feeds list. We don't need to start Anchor. All of that is handled by GitHub Actions. That's perfect. Now here's one GitHub Actions that will allow us to do all of those steps in one place. We'll pass in the image, we'll pass in the Docker file. We're also gonna look through app packages, so it'll look for npm and NuGet and Python packages as well. And then here's a fail on build command, which I haven't been able to get to work. In theory, it's supposed to fail if there are too many vulnerabilities, but it doesn't. Now, they also recommend in their docs to go grab that Anchor reports folder that this task outputs and echo it to the screen, or even better, push it as a build asset. Now I can put it inside my dashboard alongside the test results. And I'm specifically running this if always. If the build fails for any reason, I still want the reports. So let's take a look at this GitHub build. Now I have two versions of the software. In this case, here's the container scanning pass version, and here's the container scanning fail version. And I've just committed different versions of software in each place. Now you can see that with the failing one, it fails, and with the passing one, it passes. But I did some experiments here. Could I get it to pass or fail based on doing different flags? Now, here's where I was trying to use the build fail flag, but I also tried committing a JavaScript file straight into my public folder. And it didn't use static analysis of the files, rather it only looked at my package manifest. So it looked at my package.json and my packages.config and used that to be able to infer the software that was installed. So if you just grab one JavaScript file and you set it in place, yeah, unfortunately, Anchor is going to miss this. So let's take a look at the build that produced this. And this build is identical in both sides. It's just the content that it's using to be able to validate if it succeeds or fails. So we'll start off by checking out our software. Standard here. We'll do a Docker build. And in this case, I'm tagging it as container scanning and giving it a GitHub SHA as my version. Now that definitely isn't semantic versioning, but it does mean that if ever we're using this image, we'll know exactly the version of the software that built it, which might help us reproduce that build. Next, let's kick off the Anchor scan. We talked about how I can't get fail build to work, so maybe setting it to false or leaving it off might be a good move. But in this case, I've passed in my Docker file as well, and I want to include app packages. Next, I'm going to output this build results to the console. Now, that's helpful if we want to use our build output, but even better, I'm going to take those reports and I'm going to upload those as build assets. Together with my unit test results, now I can include these as the portions resulting from this build. Periodically, I might want to recheck my containers to see if they're vulnerable, and having both the container results, the content results, and the vulnerability list might be really helpful for that. I'm specifically doing this if always, so that if it failed previously, I'm still going to get these results. Now, let's go check to see if it's vulnerable. In this case, I'm looking for any vulnerability, and if I find any, then I will fail the build. Now, what if there's a vulnerability that isn't patched? Should we not allow that in our cluster? Or should we allow content at a particular level, maybe block no severe vulnerabilities, and maybe block patched vulnerabilities? This is definitely a thing that you need to discuss with your team and find your corporate level of comfort with how much vulnerabilities can be in place. Now, we've learned in this industry that just saying that there's a problem without a cure may not be the best reason to be able to block out the everything. So we took a look at a GitHub Actions run and how we can use GitHub Actions to avoid needing to sync our content. And now we have this cloud-based build that is excellent at being able to validate our containers and get this content into place. We took a look at both the failing and passing GitHub Actions scenario. That was really cool. And so you might choose to clone this repository and use that as an example, or take this methodology and use it with a different tool. Kubernetes. Kubernetes is a great mechanism for keeping our containers running, but it doesn't protect the process. The process of protecting the process running in our container is our responsibility. Kubernetes only protects itself. We need to secure the containers. This has been a lot of fun getting to show you container scanning here at Conf42. I'll be at that spot where the conference has designated for live Q&A, or if you're watching this later, hit me up on Twitter at rob_rich. And you can grab these slides and the code right now at robrich.org. Click on presentations. Thanks for joining us and getting to talk about container scanning. I'll see you in the next session.